Guys, a quick late update. Check this out. We had a comet strike the sun and then followed by an X-flare. And the X-flare is exactly aimed at the planet, almost centered. And we're going to look at the timing on that. We're going to look at the effects and the strength of it. So just hang in here a moment. Now check it out, coming in from the right lower quadrant right there. Powerful flares. We got a bunch of sunspots on the surface. But again, when we see this comet come in, you can't say it's directly related, but I've seen it many times. Out the top, bam, X-flare coming in. Now, this LASCO satellite that we're watching has two cameras. The red one you just saw that gives us a close-up image. This one that gives us a much wider image, I think about 3 million miles. Look at that comet. Now, we've seen these sundivers before, but this one is a little above the small ones that you see. It's not as big as some of the large ones, but I did notice definitely it had enough mass to make some type of impact. It's an electric universe. Now, switch satellites. Let's go to the Solar Dynamics Observatory, guys. All of these links, by the way, are on our website at bpearthwatch.com. SDO stands for the Solar Dynamics Observatory. Now, and you're going to see when we look at the tracker that it's picking up two flares. There were actually three, but two were directly Earth-facing. Here, and if you notice, guys, see these arcs in between the sunspots? Watch the energy travel from this one to here and to here. All three light up. The sun is in solar maximum, and we expected a second peak, and it looks like we're going to get there. Now, let's look at a slightly different satellite. Check out, again, that comet is very bright compared to some of the smaller sundivers that we've seen. Very good, excellent view. I'm glad we do have solar satellites like this, or we would not know what was coming. Now, this sun is very hot right now. When I said second peak in the solar cycle, that does happen sometimes. You'll have one peak and it looks like it's going to die down, and then the second peak comes in there. And look at the sunspots here. You've got something coming around the edge. It'll take a minute, but these three right here are still dangerous. Now, notice it says 7-2 because this is on UTC time. They're slightly ahead of the East Coast, I think about 5 hours. But anyway, there's a lot of power going on, and these flares threw us, or these sunspots threw us a flare that's basically going to center the planet. The reason I say that is if you drew a line across the equator of the sun, you got the northern hemisphere, the southern hemisphere. These sunspots are in the southern hemisphere. The Earth is also not perfectly aligned with the ecliptic of the equator of the sun. We are slightly below it. So anything below that has more of a direct input or impact. But still, even if it's slightly off like this sunspot, we still get the side effects. Now we're going to get the combination of two flares back to back, which they call cannibal flares. Now, in this SDO image, you can clearly see the two most dangerous sunspots, one in the northern hemisphere, one in the southern. Both were involved in the X-flare. The way you can tell is the colors designate a different magnetic component. Again, electric universe. In other words, you got a positive and a negative. When they get close enough, they're going to arc. If this one gets close enough to the red spot, it will arc, or if it gets close enough between this red spot and the blue spot, they can arc together, just like we saw. Now, let's look at the solar flare detector, guys. You can see 2 days ago, this one was not quite an X-flare. You see the red line, that designates it, but we had one here, and we've had another one. Again, we're going into a solar maximum, second peak, and the sun is very hot. Look at what it's doing to the El Nino. Look at the 36-degree fall in the Antarctic, and look at what's going on in the desert Southwest. Nature is tied from the sun to every planet, especially this one at its close proximity compared to some of the others. Now remember, we got two components to an X-flare like that. The first one is not a proton event like you see in the plasma density that we're about to look at, but you have the light effect, which is not, again, not proton, but photon. It travels much faster at the speed of light. As we watch a CME coming in, it may take 24 plus hours to reach us, but a photon or light speed event takes 8.2 minutes. And that's why you see the blackouts here on the planet, radio blackouts into the upper atmosphere. Now let's take a look at the model from the Space Weather Prediction Center, guys. Again, here's our flare, but there were two components, and you'll notice if you look at this section right in here and look at it as it passes by. Again, two sections exploded, one just minutes ahead of the other. Here we come up on the time here, you'll see the peak in the density, which is proton. Look at that. Now it's going to separate. There's two flares there. You can tell it as it passes, and you can see it here. Now let's look at the timing. Again, this is going to be pretty much a brick wall. Last time we saw it, we had two 7-point quakes in Venezuela. That's why I watch these things. Again, let's stop it. Timing here. Let me back it up just one hair to right when we hit that brick wall. Now this is midnight on the 3rd UTC time in Europe. You take 5 hours off of that, and that gives us 7 p.m. tomorrow night on the 2nd as far as the initial impact. But the reason you see two humps is because, like I said, you can see if you look closely, there was a burst from both of those sunspots because they connected to each other almost simultaneously. But again, here, it's going to drop back down. We'll see the second burst. Let me back this up. Right in here, right about there. So 5 hours later, about midnight tomorrow night, we will see the second impact. Now, let me remind you, it's just a model, and they do say there's a plus or minus 7 hours or window of plus or minus 7 hours either way on the impact, because you'll get one speed, which I call muzzle velocity, as it leaves the sun. By the time it's traveled 93 million miles to our planet, it can slow down just like the muzzle velocity of a rifle. But what they're registering is, again, very high speed solar waves, and that's why it's getting here so quickly. So don't let the numbers fool you. This is going to happen tomorrow night. First blow around 7 p.m. East Coast, second around midnight East Coast. Now, on the bottom section here, guys, we're dealing with plasma density. Again, that's the section of protons in its centimeters cubed. That is the mass and the density of this wave. If you look down, this is the radial velocity, which is solar wind speed. So here's the pressure, here's the wind speed. And so we're going to be dealing with around 600 kilometers per second during these impacts. Guys, that's much faster than it sounds. So let's put that into the calculator. Again, 600 kps or kilometers per second into miles per hour is 1,342,161 miles per hour. Guys, that's really unfathomable almost to the human mind. Think about that. Traveling very fast. Now, it will slow down some, but what that does, if you have a higher speed, you have a harder brick wall impact. And because we're in solar maximum, and because we saw it was four different quakes, 2 in Venezuela, 1 Japan, 1 California, during that event that we just saw. It depends on exactly what side of the planet, a lot of times, is exposed to the sun. Now, think about it. At 7 p.m. tomorrow, it won't be dark yet on the East Coast. You still have an hour and a half or so slightly exposed. Get to the West Coast, you got a little more exposure. You get to Hawaii in that area, Alaska, you've got more exposure because you are directly still exposed to the direct line between the sun and the sun-facing side of our planet. I saw it happen. I was tracking X-flares back a few years ago, tracked them as they came in. They hit Japan at about 2:45 in the afternoon directly. Japan was facing the sun, and the Fukushima earthquake happened. And at that time, I started notifying different people, putting videos up, and all mainstream media or mainstream scientists wouldn't accept it at all. Now they're starting to be aware of it. More and more people talk about it. But then they said it was impossible. They didn't want to rewrite any books or have to teach new classes. And that's really the problem with modern day scientists. They're stuck in a hole. They can't see out of the ditch. But we're going to get through that, guys. Just wanted to bring this up. I told you I would in the video we just watched about Lake Mead. So this is a heads up. Remember, our Father loves you, I love you, and it's a heads up. Be safe.